And finally, we're going to solve some systems of linear equations using elimination. Elimination is when we get rid of one variable when we add them together. So if I look at question A, I don't even have to do any work. I know if I just go ahead and add these together, 2x minus 2x is just 0. So I just have 4y equals negative 4, and y is equal to negative 1 after I divide both sides by 4. Again, I'll need to go ahead and find what x is, so let's pick one of the equations. It doesn't matter which. I'll do 2x plus 3, and instead of y, I'm going to use negative 1 because I know that's what y is equal to, and that equals 5. So let's go ahead and do the multiplication, and let's add 3 to both sides, and I get 2x equals 8, or if I divide by 2 on both sides, x is equal to 4. So this is the point 4 comma negative 1. Remember, we always list x first. Even though I found the value of y first, when I write it as an ordered pair, I have to write x first. Now let's look at part B. This one we are going to have to do something to, because if I leave the two equations like this and add them together, nothing goes away. So I'm going to try to get rid of the x's. What I'm going to do is multiply the first equation by 2 and the second equation by negative 3. When I do that, my first equation becomes 6x plus 10y equals 2, and negative 6x plus 9y equals negative 21. I chose the 2 and the negative 3 because I knew when I multiplied the 3 by 2 and the 2 by negative 3, they would end up adding together and getting 0. So I have 0x plus 19y equals negative 19. I divide both sides by 19, and y is equal to negative 1. I'll go back to one of my original equations. Let's use the 3x plus 5y equals 1. I'm going to substitute in negative 1 for y. And when I multiply this out, I get 3x minus 5 equals 1. Adding 5 to both sides gives me 3x equals 6. And finally, dividing both sides by 3, I get x is equal to 2, or a final solution of 2 comma negative 1. And one final one. When I look at this, I see if I multiply the second equation by negative 2, let's leave the first equation alone. I'm going to multiply the second equation by negative 2, so I'll get negative 4x minus 2y equals negative 6. And when I add these together, the x's are gone, the y's are gone, and I'm left with 0 equals negative 4. Well, we've run across this situation where we had 3 equals 3, and I said for that there was an infinite number of solutions, because no matter what I picked for x, 3 is always going to equal 3. Well, in this case it's similar, but a little bit different. No matter what I pick for x, there is no way that 0 is going to equal negative 4. There's nothing that could make 0 equal negative 4. So in this case, there are no solutions. This is just like when we graphed them in the first part. They are parallel lines, so they'll never ever cross. So if you ever get something like 12 equals negative 1, 0 equals negative 4, two sides of the equal sign that don't match, that means we have no solution. If you have an equation such as 3 equals 3, negative 10 equals negative 10, or 0 equals 0, that means there's an infinite number of solutions. And lastly, the one that we run across the most is you have one solution. So these are the 3 different types of solutions you can have with a system of linear equations.